Howdy again, it's tubalcain, your YouTube shop teacher, and welcome to a new video. And today I'm starting a new project a little bit different than what I usually do, and I'm going to try to restore, I should say rebuild, or bring to working condition this beautiful Empire hot air or Stirling engine. Now you saw this in a recent video where I unboxed it. Remember, that was the box that the post office played kickball with all the way from San Diego to my house, but this was sent to me as a gift, and I'm very thankful to Bob Kern, who is a collector of Empire engines, and sent this to me. He had several of these. This was a parts engine. He has one or more that are in running condition and can be seen on YouTube, or perhaps they're not his that you're going to see on YouTube, but you're going to see several of these in operating condition running. Now, I have done at least a dozen videos over the years on hot air engines, so take a look at those if that interests you, but they were not viewed by very many people, so I don't think there's a lot of interest in hot air engines, and I'm not going to explain how this actually works. I'm going to work on it and try to get it running and explain things as I go along. It'll probably be a multi-part video. But if you actually want to see how they run, look up this video of mine, do a search on YouTube, and there were a lot of people that watched this, about 126,000, so I think I explained it in very thorough terms, so look at that if you're in the mood. Let me talk a little bit about Empire engines. And here it is. This is my rather modest collection of Empire steam engines, and they were made by the Empire Metalware Corporation, Two Rivers, Wisconsin, probably in the 20s, 30s, 40s, maybe even into the 50s for quite a length of time, but and they were all electric, as you can see. And in addition to these, there were several other models that I'm aware of. There also was a turbine model, which I have seen and never owned, and they made the one Stirling engine that I just showed you. These were patented by various people, and the patents assigned to the Metalware Company, and I'm going to talk about the patents in just a minute. I don't know so much about patents of this type, but patents on the Stirling engines, and they were all very sturdily built and quite heavy, cast iron and brass and copper and all the real good metals, no plastic on these at all. Some insulated parts out of wood, but just quality construction. However, this must have been one of the later models, this one too, where they cheapened them up and made a so-called tin base rather than the cast bases. That's all I'm going to say about the steam engines, because I'm not sure there's any interest in that, but I do have some other videos showing those. Now let's get back to that Stirling engine. Apparently very few of these were made, and the reason would be they probably were a little bit too expensive, and the other thing is there'd be little interest, because once you got them fired up and running, there wasn't any tending to do like there was on a steam engine, so you would just sit there and look at it, and would in fact be no more interesting than looking at an electric motor running. So you know that's not going to keep the interest of boys very long. But one thing that Bob suggested, that these were used in the window displays. Remember, they used to display in toy stores various toys, and if they were in motion, it fascinated people. Back in the olden days, it wouldn't now. But these would not require no attention. They could plug it in and let it run all day, where if they put a steam engine in the window, it would have to be constantly monitored by a clerk and probably eventually burn up for lack of water. But these could also power, so you see there's a pulley here, in a store display, I'm told, by belts and shafts and everything. They could run the steam engines powered by this, strictly for display purposes and probably safe from fire. And here again is the tag from Two Rivers, Wisconsin. 350 watts, and it's a model B38. I understand that there were several models of these. Some had cooling fins on them. This one, at first I thought the fins had been removed because you see in the patent drawing here there's fins, and quite often there's cooling fins on hot air engines, but none on here, so apparently it will run without them, at least for short periods of time. If such a thing would interest you, there's the patent number. You can look that up, and there's about 3 or 4 pages of text as well explaining the patent, and that goes back to 1927, and it was patented by this J. Koning, I believe it was, but the patents assigned to the Empire Company. And there's another view of it, and this is going to be most important to me because I had no idea what was missing or how it functioned. Well, I know the principles of it, but this is quite a bit different in its construction than the other ones that I use. So this is going to be my resource. As you know, there's a displacer piston in here. Actually, it's called a displacer, but in the patents they sometimes call it a piston, but that's incorrect, at least now. And here's the power piston that goes in the cast iron cylinder right here. This is bent and needs to be repaired. You can see there's a bend in it, but it's very heavily constructed and nicely made, and it goes onto the flywheel right here. On this side you can see that we have 2 bearings right here with oilers and a 1/4 inch shaft, and remember that this pivot point here is 90 degrees out of phase with the one over here on the flywheel. Looking inside here, I don't know if that shows up or not, there's an oiler right there also, so this is really neat the way it's constructed. Now this is a double wall here and hollow, that's aluminum. All of the rest over here is cast iron. So what is missing, you say? Well, first of all, there's a cover here that had the heating element on it, and that's probably why it was taken apart. That either failed or generally what happens with any little toy like this, a boy took them apart, and that might be 50 years ago. And of course they didn't put them back together because once they got it apart they had no idea how to repair it or knew how to get parts or had any money, so Mom threw away the parts, and this somehow managed to get saved. But if you look in here, this piston rod is either broken off or cut off or something, so I have to deal with that. So I just talked about the double wall here. Looking in here now, you can see what's left of it, or what it looks like from the inside. And someone wrote on here a long time ago 1 3/8 stroke, and that refers to the stroke right here, which is 1 3/8. And this is 3-inch diameter, exactly 3-inch diameter. The power piston is 1.312 diameter. I put all those orange tags on there. They look like price, well, they are price tags. I'm using them as information tags. And this has a 1 1/2 inch stroke on this side. So the piston, the brass piston, moves 1 1/2 inches back and forth. And again, 1 5/16 diameter. All one piece, pressed. Wow, that's nice. I don't know what this is. I thought it was an oiler, but there was nothing on the inside. And that's just the head, just a stamped piece of steel. A lot of stampings because that's the kind of company that they were. I think these old drawings are just so awesome. It would all have been pen and ink on the patent drawings, done to certain specifications, and look at the lawyers' names on that, and all done with ink pen. Really neat. Now you will notice that this is almost a reverse image of the actual engine that is setting over here. And a patent drawing didn't always totally resemble the final product. There was a concept there that they were patenting. notice that they call this a conduit. I would have called it a pipe, but the conduit connects the power piston, power cylinder with the displacer. But here's what is missing. You saw that there was some piston rod that was, I said, might have been cut off, so it's apparently was cut off right about here. But this displacer, which looks almost like an H, is missing, as is the other end of the rod, right in there. And this piece, whatever it is called, is missing, and it had the heater element in it. But notice that the power rod here, the piston, rather, the displacer rod extends into this piece for support. The whole idea of the displacer is to move the hot air from the hot end down to the cold end. This is a so-called cold end, and there's contraction going when it goes in one direction and expansion in the other direction, and that pressure or lack of it is translated through the conduit to this. I said I wasn't going to try to explain that. Go to the other one. That's all I'll say about that. But I thought it's really neat. Also, there's a tiny little hole here at 26 so that this doesn't act like a piston, and or I should say like a little compressor, and cause friction, because you can't have any kind of friction in an engine like this. Very little power is produced, and if there's rubbing or anything like that going on, it just isn't going to work. And how am I going to get this thing running? Well, there's nothing wrong over on this side other than that bent connecting rod, so I don't need to worry about that at all. That'll be real simple. But what is missing and needs to be built on this side, again, I need a new shaft, I need a new displacer, and then this whole end piece. And I'm just thinking about this. I spent a lot of time thinking about this. I already have for several weeks. I'm not even thinking at this time about the heater. This shows very little of the heater, and it would have been, of course, a resistance unit. I hope to get it running on an alcohol flame, and that will satisfy me that I do not need to necessarily have a plug-in. But surprisingly enough, I know I'm gabbing a lot here, but if you're still listening, you're probably interested in it. Several things were mentioned about safety in this 1927 patent. Safety for the children, safety from being burned or electrocuted, so that was mentioned. Also, repeatedly they mentioned that they wanted the toy to be sturdy and not fail and require a little maintenance or attention, so that was in the patent. I could start with solid bar stock aluminum because it needs to be as light as possible, and I don't even have any aluminum that large. I'd have to wait till the weather gets warmer and make a casting, but there's just so much work to that and so much machining. I'm really hesitant to do all that, then get halfway through and not have the thing work, and that would be extremely discouraging, and I know I'd quit. And if I quit, of course, you wouldn't be seeing this video at all. But I just went to Walmart because I'm looking for some kind of container or cup or something that I could use in here that would be 3 inches. Well, it's got to be a little less than 3 inches, and it's got to have a thin wall. Well, of all things, a Progresso, I think that's Progresso brand soup can, is just a little bit under. So I'm wondering if I can do anything with that. Now watch this. This will go all the way in, so it's gone even in this double wall deal. Now how do I get that out? I gotta have a magnet here or something. Where's my magnet? Okay, but if somehow this could be modified, and I wish it didn't have these corrugations in it. So here's another brand. I don't know what that is, but that would be neat because in the middle here it is solid for just a portion. If only I could cut it off, you know, here, and then have that that solid portion, which you see right here, in the middle, and that could be a piece of aluminum. I don't want to make it steel. Steel would be nice because then I could solder it in. So that's where I am right now. Now this one's a little too large here because of this lip here, but that can be cut off. But this one is larger than this. It's not going to fit. And I could find nothing at Walmart, and those things that I did find were tapered or made out of plastic. Well, I need metal. I could start with a piece of sheet metal and roll it, but then I'm going to have a lap seam on there, and it's not going to run true. So I really like to machine things, but I would like to start with something like this and make a mock-up and see if I could get it running and see if my concept or my idea of rebuilding this is valid. In my experience over the years in repairing things and building things, I was always trying to use what I could find in the shop or in a junkyard or whatever. And I was almost always unsuccessful and wasted so much time, and I'm wasting time right now because looking through my shop, there's a piece of large aluminum, but it wouldn't be long enough, plus it's got that hole in the middle. Well, that might have helped me, but you know, there's a piece of solid, but it's 2 3/4. I marked that years ago, so that's not going to work. So what I think I will do, without further ado, is to make a mock-up using this can, cutting this off so that I can determine at least the lengths that I need and the diameters, and in other words, a model so I can think about it, of what all is entailed. I think this outer cup that is screwed to this can be cast aluminum, but again, I'd have to make a pattern for that. And you can see that I'm already testing to see what size the screws are. That's a 632 screw, so those are 632 common, easy to find threads, and that's a relief for me. And you notice that all of the dimensions, you know, the 3 inches and the 1 5/16 and the length of the strokes is all common fractional sizes that is easy for me, or we who love the imperial system, to deal with without the nightmare of, well, you know what I mean. This is the perfect can for my experiment, and it's a seamless can, and it's a so-called 2-piece can, so that's all one piece drawn on the bottom. And I've got some older cans around here that got the seam on them, but that's not what I want, and that's a separate bottom. And the other cans that I have don't fit. That's a different size. So anyway, luckily my wife just went shopping, so up to the kitchen we go. Alright, here we are at the cupboard. Let's see what she's got. You see there's all kinds of soup cans, and some of these are bigger. When I worked at Del Monte years ago when I was in my prime, the cans had numbers like 303 and all that, but I don't know if they still do that. But you can see that these Campbell's cans are too big. So are the Progresso, way too big. And the little old Campbell's, nobody buys that anymore. It used to be 9 cents a can. I live in the past. All right. Hunt's chili, that's the right diameter. That's pretty much the same can, you know, and all right, she'll never miss it. Well, here we go, and I guess we won't be having chili tonight. I had a heck of a time with that can opener, and it's still not opened properly, but I got to get rid of this and hide the evidence. And holy mackerel, looks like somebody had a real bad case of hemorrhoids. I'm back over at the bench, and I'm going to save the label so I can remember to buy more of those if I need more cans, because this is just an experiment. I don't know how long to cut them, so I'm sure I'm going to need more. And the whole idea now is to take 2 cans, identical cans, and put them back to back like that. And then I got to cut them to length, and which is no easy job with this thin metal. And then the rods, that's the piston rod now, is going to run in here. It'll be more or less like that. And I'm already making a new one here. This is the original, and I told you it was cut off. Well, it's like a combination of being cut off and broken, and that might be like I say, 50 years ago. But I've already made one, and this was a little more work than I thought, considering this is, again, just a sample. I know that I won't have all of the dimensions right, but I got it slotted, and I got the cross hole drilled, with this, which is 1/8 inch, and then I was able to mark it, as you can see there, and I need to turn down everything from my thumbnail to the end to 5/16 diameter. So let me get started on that, but before I do, I should say, don't let me get ahead of myself here. I'm going to drill the holes in the bottom of the cans, and I'll show you how I'm going to do that, so I get them perfectly centered. If they're not concentric, this is going to rub, and I need it to not touch, and it's so close to the diameter, that the 3-inch diameter, that might be impossible to do. Well, this concludes part 1 of a 3-part video on the rebuilding of this Stirling engine, and it's just a long rebuild, and it's going to take more than one video, so I hope you stick with me as I go on to parts 2 and 3 and hopefully get this thing running. And it's been a little bit tougher job than what I thought, and I'm glad I have a complete shop, and I hope you're enjoying this. So I'll see you in part 2.